explain the concept of percent increase or percent decrease. So let us start. Let's suppose A is any physical quantity and delta A is the increase or decrease in A, then delta A which may also be denoted by dA is called absolute change or absolute increase or decrease. And if we divide delta A by A or dA upon A, delta A is divided by A, which may also be written as dA upon A. That means the change in A is divided by its original quantity. That is called relative change, or relative increase or decrease. And if we multiply this relative change by 100, it turns out to be percentage change or percentage increase or decrease. And this may also be written as dA upon A into 100%. That is percent change or percent increase or decrease. Increase or decrease. So now let us start. Solution. So here in this problem we are provided with two informations, that is P into V raised to the power 1.4 is equal to K first, and second is there is a 0.5% decrease in the volume of the gas. So let dV be the change or decrease in the volume the percent decrease, which is denoted by dV upon V multiplied by 100, that is given half. But that should be taken negative if it is decrease and positive if it is increase. Here we need to remember one thing, that if there is decrease percent, so that should be taken negative, and if there is increase percent, that should be taken positive. So since in the problem there is decrease of 0.5% in the volume, so we have taken it negative. So now taking log on both sides of equation 1. This is very important to remember, that if we need to find out percent change, whether it is a percent increase or percent decrease in any physical quantity, we must take log on both sides of that relation. So if we take log on both sides of equation number 1, we get log P into V raised to the power 1.4 is equal to log K, and since log M into N is equal to log M plus log N, so we may apply this relation and this rule here, and we may write it as log P plus log V raised to the power 1.4 is equal to log K. Now, as we also know that log M raised to the power N is equal to N log M. Using this rule, we may take this power of V 1.4 as a coefficient of log. So log P plus 1.4 log V is equal to log K. Let it be equation number 2. After that, differentiating equation 2, we get one upon P into dP plus 1.4 1 upon V into dV is equal to 0, because K is constant, so log K is considered to be constant, and differential of constant is 0. So we get this. Now this may be written as dP upon P plus 1.4 dV upon V is equal to 0. Now multiplying the whole equation by 100, we get dP upon P multiplied by 100 plus 1.4 dV upon V multiplied by 100 is equal to 0. Now as it is already given in the problem that dV upon V into 100 is equal to minus half, that is decrease percent in the volume. So we may write here minus half percent. So we get dP upon P into 100 multiplied by 1.4 multiplied by minus half percent is equal to 0. As we open it up, dP upon P into 100 as it is, and as we open this bracket up, this minus will multiply this plus and becomes negative. 1.4 upon 2% is equal to 0. So we get simply dP upon P into 100 minus 0.7% is equal to 0. Now transposing this term to right hand side, we get dP upon P into 100 is equal to 0.7%, and since this percentage has positive sign, so simply it is percentage increase in the pressure. So we got the answer. If there is decrease of 0.5% in the volume, there will be 0.7% increase in the pressure.